My name is Jack, and I'll be explaining our results and discussion.
Hi, my name's Jared, and I'll be discussing some of the results as well as the conclusion.
And hi, I'm Christian, and today we'll be discussing the topic of the role of NAD+ in biological oxidation reactions. Hard extract will be used to determine whether it will oxidize the following substrates: pyruvate, lactate, succinate, and malate, in the absence or presence of NAD+, and whether malonate affects the oxidation of substrates. I'll now hand you over to Jared, who will explain which tubes are controls and why we chose to include these tubes.
Test tubes 1, 2, 3 and 4 were our controls. In number 1, there was DCIP and hard extract, used to see if DCIP would have any colour change with hard extract alone. Number 2 had malonate DCIP and hard extract, which was used to see if malonate and DCIP would cause colour change without substrate. And number 3 was NAD and DCIP, which was used to see if there would be colour change with both electron acceptors, but without substrate. And finally, number 4 was DCIP, NAD and malonate, which was also used to determine if there will be colour change without the addition of substrates.
I'll now hand you over to Jack, who will explain the results and the discussion.
The reason why our actual results did not have any color changes besides test tube 11 is due to a variety of factors we took note of during experimentation. The first reason was that our test tubes was not thoroughly mixed after placing all the required reagents in each test tube. This could be the main reason why the reactions took too long to show any color changes. An attempt to mix these test tubes was made at about 19 minutes into our timing, but at this point, we ran out of time to continue to see if our test tubes had any reactions occurring. Another reason why we did not yield any color changes in our test tubes could be because of the extra 2 mL of phosphate buffer we added to the hard extract solution. The reason we added extra phosphate was because we did not get the estimated 16 mL of hard extract to place in the 16 test tubes. This means that the amount of hard extract we placed in each test tube was slightly lower than expected. Another issue we noticed after realizing that the color change did not occur during the times we expected was that the heat of the test tubes seemed to dissipate too quickly. This can drastically reduce the rate of reactions for NAD+ in the citric acid cycle. And lastly, another issue we noticed after our timing for the reactions is that the amount of water added to some of our test tubes was not accurate. We added an extra 0.5 mL of water to test tubes 4, 5, and test tubes 8 all the way to 16. Water was added to ensure that the volumes of each test tube stayed constant. In theory, the amount of water added should not affect the rate of reaction of our test tubes because they do not interfere with the reactions directly. However, we believe that it is the combination of all of these factors, the lack of mixing, the reduced hard extract content, and the heat dissipating too quickly, we get nearly all 16 of our test tubes having no reactions taking place at all. Although, we were still able to analyze the expected results given by our demonstrator, so we'll analyze that instead. Test tubes 1, 2, 3, and 4 were used as our controls. Using the results given by our demonstrator, it had no color change because it lacked either the substrates pyruvate, lactate, succinate, or malate. Test tubes 5, 6, and 7 contained the substrate pyruvate. None of the test tubes here had any color changes also because it requires NAD+ and other cofactors, namely coenzyme A, for the reaction to proceed. Test tubes 8, 9, and 10 contained the lactate substrate. Only tubes 9 and 10 had reactions occurring at 16 minutes and 17 minutes respectively. This indicates that the reactions for lactate only occurs when NAD+ is present, since test tubes 8 does not contain NAD+, and consequently had no color change. Test tubes 11, 12, and 13 contain the succinate substrate. Tubes 11 and 12 change colors at 4 minutes, while tubes 13 change colors at 17.5 minutes. Since all three test tubes had reactions occurring, it shows that succinate can oxidize without the presence of NAD+. But in the presence of malonate, a competitive inhibitor for succinate will inhibit the reaction and therefore increase the time for oxidation. And finally, test tubes 14, 15, and 16 contain the substrate malate. This is similar to lactate in that the reaction will only occur when NAD+ is present. The presence of malonate also seems to inhibit the rate of reactions in test tube 16, since it took 4 minutes longer to react compared to test tube 15, which had no malonate present.
Now hand you back to Jared, who will explain the differences between lactate and succinate in the presence and absence of NAD+, as well as what this data tells you about the relevant enzymes involved.
Tubes 8, 9 and 10 were for lactate. 8 had no NAD+, and notably did not induce any colour change. Tube 9 had NAD+ added, and there was a colour change after 16 minutes. Tubes 11, 12 and 13 were the succinate reactions. Number 11 had no NAD, and there was a colour change after 4 minutes 21 seconds. Number 12 had NAD+ added, and the colour change was very similar, happening after 4 minutes and 16 seconds. Because of the similarity in the time taken for the colour change, we can conclude that the NAD+ was not needed for the succinate reaction to take place, and conversely, for the lactate reactions, NAD was shown to be necessary, with no colour change taking place without it.
The question is, which reaction does malonate affect? And I'll explain this by referring to the structures involved. Malonate is a competitive inhibitor of the enzyme succinate dehydrogenase. It is a structural analogue of succinate. As seen above, malonate binds to the active site of the enzyme without reacting. As explained before, malonate is a competitive inhibitor of succinate. It also inhibits malate, shown above, as malonate stops succinate being converted to fumate. This also stops the oxidation of malate occurring, which is seen above in the Krebs cycle.
To conclude the presentation, I will address some key questions that were focal in design of the experiment. Out of the 4 substrates, only the succinate reaction took place without NAD. There were separate reactions that were tested with the presence of NAD, which all took place except for pyruvate. The oxidation rate for 3 of the 4 reactions was altered with the presence of malonate. The succinate reaction was inhibited greatly in terms of the time taken to change colour, while lactate and malate were only slightly affected by malonate. Thanks for watching.